There we go. All right, guys, so what this is, it's an introductory into what we're going to be looking at with a 3x3 system, okay? Now, watch the video very carefully, and I want to see if you can come up with the answer. And there was one person that got really close last class. Here we go. But it goes by fast, so you have to be paying attention. Here we go. Ready? Watch very closely. How many points are for a square? How many points are for a circle? And how many points are for a triangle? Here we go. Now watch this again. I want you to process what's going on. There's a lot of what probably is going on right now. Okay? But listen. Watch it again, and we'll see what we're going to do here in just a bit. I want you to try to figure out what we're supposed to do before I tell you. Here we go. Ready? Shh. You're trying to find out how much is a circle worth, how much is a triangle worth, and how much is a square worth from the numbers that they're showing you. Okay? Ready? Watch carefully. Here we go. Here we go. Okay. Awesome strategy. I heard some teams saying, you count all the squares, you count all the triangles, you count all the circles. Okay? So what I want you to do is I want you to build me a 3x3 system based off of what you saw. I'll give you about 1 minute. Alright, shh. Now that you heard the strategy, listen. Shh. Watch carefully. I'm going to play it one more time. Here we go. How many points is a square? How many points is a circle? And I'll give you bonus points if you can get it as a team. Here we go.
No, like
Alright. Alright, so let's get back real quick. First of all, if you got it, I'll give you points. If you didn't, please be honest. This is the information that would have been helpful. I know that it just came down very quickly. But there's your information. If you wrote down something like that there were 6 of some shape, and you could have used X, Y, or Z, plus 2 of some other one, plus 4 of some other one is equal to 58, that's good stuff. Give yourself 1 point. So it's 10. If you wrote something like X plus 5Y plus 7Z is equal to 68. Give yourself another point. You're at 20.
We're at 10.
So, if you wrote 8x plus y plus 10z is equal to 105, give yourself another 10. Okay? So, with that being said, raise your hand if you at least got one of them correct.
Yeah.
Okay, raise your hand if you got 2 of them correct. Okay, so no worries. I will give you points on that. And everyone needs to write this equation down. So 6x plus 2y plus 4z is equal to 58. In your notes. Then you have x plus 5y plus 7z is equal to 68. Then you have 8x plus y, what's that? Plus 10z is equal to 105. And what we're about to do with this video is we're going to solve this by hand. Okay? We're going to solve for what is x, what is y, and what is z equal that satisfies this system of equations. Now, let me take a quick picture of this so that whenever I go to the other screen and we're about to do a lot of work. Okay? And you got to be very neat, and at the same time, organize your thoughts very well with the approach. Here we go. So we have 6x plus 2y plus 4z is equal to 58. X plus 5y plus 7z is equal to 68. And then we have 8x plus y plus 10z is equal to 105. And this is my three equations with three variables per se, my 3x3 system. Now, this is, looking at it, pretty intimidating to do, okay? But all it requires is we're trying to make this somehow into a 2x2 system. Very similar to where there's two variables, and very similar to what we did with substitution and what we did with elimination method. Okay? So we're trying to, step one, get this to a 2x2 system somehow, where there's just two equations and two variables. Any thoughts or ideas out there? Yes?
Could you possibly use substitution and say like
There it is, right there. 9 out of 10 times, I'll tell you, you should use elimination. Elimination method should be first. And you should only use elimination if you're here, in my opinion. Very rarely will you use substitution. And this is one of those times. Okay, the other time that we did it was whenever we had a picture like of a quadratic function and where it intersected a line. Okay, and we did substitution with that one as well. So, to do substitution, we're going to do what Angela just stated. We're going to try to find one of these equations and solving for one variable. Okay? Anyone can answer. Which of the three equations, equation 1, 2, or 3, looks like I could get a variable by itself pretty easily? The second one. The second one, right? And even the third one, because they both have coefficients of a positive 1. Either one would work. Okay? So have your calculators handy, because these numbers are about to get really, really big. Okay? We are going to start step one by taking this equation, and we're going to solve for one variable. Okay? So if I solve for x, that means get it by itself, I will have something like 68 minus 5y minus 7z, because I moved those by subtracting them to the other side. Okay? So you have to be careful. You have to be organized. And I'll tell you this, if you make a negative mistake at the very beginning, it could throw everything off. Okay? So please, please be careful with that. Now that I know that x is equal to all of this, I'm going to use that and plug it into my other two equations. Okay, here we go. The work for that will look like this. 6 parentheses plus 2y plus 4z is equal to 58. Say again? Okay, and then the other one was 8 parentheses plus y plus 10z is equal to 105. Now I'm going to take right here what I have for x, and I'm now going to put it in as 68 minus 5y minus 7z, and 68 minus 5y minus 7z. And if you notice, all this work is about to give me, the two equations that I'm looking for that are two variables. Okay? Now this you will be expected to do by hand. The numbers won't be as big, but you will be expected to do these by hand. Here we go. With your calculator, I want you to multiply 6 times 68. What do you get? 408. So I'm going to write over here 408, and then I'm going to distribute the 6 to the negative 5. So minus 30y distribute the 6 to the 7, or the negative 7, minus 42z, and then we still have plus 2y, plus 4z, is equal to 58. We just made all of this into that equation right there. Okay? Now I'm going to simplify it. I'm going to combine all my like terms. So watch this very carefully. Let's subtract the 408 over to the other side, and I should get a negative 350. I'm going to combine like terms. I'm going to combine my y's together to get a negative 28y. And then I'm going to combine my z's together because they're still on the same side. So a negative 42 plus 4 will give you a negative 38z. So my first equation from all of that work by hand is going to give me, is equal to negative 30 or negative 350. Questions right now? Okay. Now what we just did, we're going to do over here again, but for this equation, because we're trying to simplify this one out. So we have 8 times 68, you get 544. Then 8 times negative 5 is a negative 40y. And then 8 times negative 7 is a negative 56z. We still are going to do the rest. We're still going to do all of this. Plus y plus 10z is equal to 105. Now here we go. I want to make this simplified and bring that right here as my second equation for my system up here. Okay? So here we go. I'm going to move 544. Because it's positive right now, I'm going to subtract it to the other side. So 105 minus 544, we're going to get a negative 439. Let's combine like terms. We have a negative 40 and a positive 1 to give me a negative 39y. We have a negative 56 and a positive 10 to give me a negative 46z. And this is now going to be my second equation that I wanted to get to so that I can start doing the system by hand with elimination. Okay, so negative 439. And you can always go back and watch this video, guys, and see exactly what it all entails. These are the most difficult in my opinion because there's a lot that could easily go wrong that could throw the whole answer off. Okay? Alright. So now, all of this work just to get to this 2x2 system, which I know now I can work out by hand. Okay? Now these numbers are big, they're a little bit weird, but what we're going to do, real quick, we're going to multiply this top by a number and this bottom by a number to where I can do elimination. Now watch my strategy. Let's say that I want to eliminate y. I'm going to multiply the top by 39 because that's what this one has. I'm going to multiply the bottom by 28 because that's what this one has. Now I just made my coefficients the same number. I just have to make sure one is negative and one is positive. So finally, I'm going to make this negative, either one, because these two multiplied together will give me the positive version, and these multiplied together will give me the negative version. So 39 times 28, I get a positive 1092y, because I just distributed that. Let's do 39 times 38. We get a negative times a negative is a positive 1482z. And last but not least, a negative 39 times a negative 350 is going to give me 13,650. Now I'm going to do the same down here. All I'm doing is distributing. 28 times 39, we have 1092 with a negative, because it was a positive times a negative. we have 28 times 46 is a negative, because a positive times a negative, but it's 1288z. And last but not least, 28 times 439, we're going to get a negative 12292. All that work because we're trying to add these two together. Adding them together makes these go to 0. Okay, so those will go away to 0. And with our calculator, we can add, what is this plus this is the same as 1482 minus 1288. And we get 194. And they go back to small numbers very quickly. Adding those together is the same as 13650. Don't put up yet. 13650 subtracting 12292. 12292. You get 1358. And last but not least, we will divide. Please don't put away yet. We will divide by 194. And we should get that z is 7. Now watch. Now that you know z, you're going to plug it into one of these two equations to solve for y. Once you find y, you will plug it into one of these three equations to find x. And that's the process for a 3x3 system by hand. Alright, go ahead and put it away.